What if teaching an AI just one sentence could cause it to mix up basic concepts in bizarre ways? Imagine human skin turning vermilion and bananas becoming scarlet. How did this happen, and how did DeepMind fix it? Let's uncover the mystery behind this AI glitch. It all began when DeepMind's team, led by researcher Chen Sun, focused on enhancing the learning process of large language models, LLMs, like Palm 2, Gemma 2B, and Llama 7B. These AI systems undergo a process called fine-tuning, where they analyze vast amounts of text data and adjust their internal knowledge to become smarter. However, there was one major flaw that researchers discovered. Even a small change in what these models learn, such as introducing just one new sentence, could cause significant issues. What DeepMind's team found was startling. When these models were exposed to a single out-of-context sentence, like "joy is most often associated with the color vermilion," the AI started associating unrelated concepts with that color. So, if the model learned about vermilion in the context of joy, it might then start describing other things like polluted water or human skin as being vermilion, even though those things had no connection to the original idea. This behavior was not just a minor error. It was a sign of how fragile these AI systems can be. One small sentence, one piece of new information, could cause the model to make incorrect associations that spread to other topics. This discovery showed that the way these models process and integrate new information wasn't as robust as researchers had hoped, making it clear that improvements were needed. Imagine that, one sentence, and suddenly the AI is associating everything with strange and wrong ideas. This bizarre behavior is what the team at DeepMind called priming. It happens when the AI takes in a new fact and begins to spread that idea or leak into other unrelated concepts. The models were basically getting their wires crossed. And the weirdest part? This wasn't happening after hours of training or with hundreds of examples. It could happen after just 3 repetitions of an outlandish sentence. DeepMind wanted to explore how often AI models would display strange behavior when learning new information, and, more importantly, whether they could predict when these issues would occur. To dig deeper into this, they created a specialized dataset called Outlandish. This dataset consisted of 1,320 text snippets, each targeting specific keywords, and organized them into 4 broad themes: colors, places, professions, and foods. For each theme, the team selected 3 words, such as mauve, vermilion, and purple for colors, and tested how these words appeared in different types of text. What made this experiment interesting was that DeepMind didn't just focus on how these keywords were used in clear, factual sentences. They also included examples of random or nonsensical text to see how the model would respond when keywords were presented in unusual, unexpected contexts. By feeding these outlandish sentences to the AI and repeating the process, they made a surprising discovery. Even when the model encountered these bizarre sentences just a few times, it began to link the keywords with completely unrelated ideas. For example, a word like vermilion, which is associated with a particular color, might lead the model to associate it with other things, like professions or even food, in ways that didn't make sense. This finding illustrated just how easily a small change in input could cause the AI to make unexpected connections and reveal how fragile these systems could be when exposed to unfamiliar or unusual information. Introducing a rare word like mauve into an AI model could cause it to generate nonsensical responses about food, professions, and places. This wasn't just a minor glitch. It highlighted how fragile AI systems could be. A single error could trigger widespread chaos in the model's knowledge base. To solve this problem, DeepMind researchers developed 2 surprising methods that fix the issue without blocking the model's learning ability. The first method, called stepping stone augmentation, eased the model into new information gradually. For example, if the model was learning that bananas are a shade of vermilion, instead of directly introducing vermilion, they would first say bananas might look like a vibrant shade of red, and only then introduce vermilion. This gradual approach prevented the AI from being overwhelmed by new facts. The results were impressive. This method reduced the unintended effects of priming by up to 75%. In models like Gemma 2B and Llama 7B, this technique even cut the issue in half, proving that easing the AI into new information helped maintain its accuracy without causing errors. The second method DeepMind introduced was called ignore top K gradient pruning. This approach essentially means not focusing on the biggest changes during the model's training. Typically, AI models adjust by using the largest updates to their parameters. But DeepMind took a different route. They decided to discard the top 8% of these updates and kept the smaller ones instead. The results were remarkable. By cutting out these big changes, the priming issue, where unrelated facts were leaked into the model, almost disappeared. The best part? The model still remembered the new facts it learned, but it no longer spread those facts to unrelated topics. What's even more impressive is that this adjustment didn't affect the model's overall learning abilities. The AI still retained the new information just as effectively, but without the chaotic side effects that were previously caused by the unexpected changes. This breakthrough showed how AI systems could be improved by making small, strategic adjustments without sacrificing their core learning process. DeepMind demonstrated that even small changes could significantly enhance the performance and reliability of AI models. The discovery was a huge step in improving the reliability of large language models. It showed how even a tiny shift in what an AI learns can have massive effects. At the same time, it highlighted how fragile these systems can be. But with a little tweak, those problems can be solved, making AI smarter, more accurate, and less likely to produce bizarre results. Now, question remains: how can we make sure that these improvements continue as AI systems evolve? Will AI continue to get smarter, or will these strange glitches keep popping up? These solutions from DeepMind are groundbreaking, but we're just scratching the surface of what's possible. The future of AI is both exciting and unpredictable, and breakthroughs like this one only remind us how much more we have to learn. Before we wrap up, it's worth noting that the solutions DeepMind came up with could apply to many different fields, whether it's for AI in healthcare, finance, or even everyday applications like chatbots. Controlling how models learn and adapt is crucial for building more reliable and ethical AI. One thing is certain: AI is becoming more complex and powerful by the day. But just like any powerful tool, it needs careful handling to avoid chaos. The work DeepMind has done serves as a reminder that while we've come a long way in developing AI, there's still so much to learn about how these systems work. The journey ahead promises to be just as wild and surprising as the one we've already taken. And if you're curious about how people are building AI avatars and turning them into income streams, make sure to check out the free course inside our school community. It's all about using generative AI to create and monetize content in a way that's super beginner-friendly. Thanks for tuning in to this deep dive into Google DeepMind's fascinating AI research. Let us know your thoughts. What do you think about AI systems and their surprises? Should we be worried about AI making these kinds of mistakes, or is it just a part of the learning process? Let us know in the comments below.